Hello and welcome to this part 2 of understanding polymorphism. In this episode we're going to be looking at refactoring the code that we left off in the previous episode, and the refactoring will involve some adding a library where all of these the thumbnailers are residing in, and cleaning up the code in such a way that it'll be more like a real world system. Some of the signatures here will change to include some incoming parameters and some return types and such. And the only part that we won't be implementing for real would be the actual thumbnailing part. But for the rest of the system, it would look almost like it would in a real world. So we'll be spending some time refactoring this code, and I'll also be introducing you to the factory pattern. In other words, this method here that essentially creates an instance of one of the thumbnailer base descendants will be moved into a factory, a simplistic factory, but nonetheless it's a factory, so you get an idea of the factory pattern as well. The factory pattern does not use polymorphism per se, but it certainly enables this style of programming, which is being able to program in terms of the base class, allowing you to then manipulate the object in a uniform fashion. Okay, so let's get started with this. Now what's going to happen is we're going to add to our solution here. Instead of just having one application, we'll have a library project here, and the library project will be used or referenced by the console application. The console application we'll treat as a UI application, if you will. So I'm just going to add new project. It's going to be a class library project. I'm going to call this thumbnail lib, and I'm going to start moving the classes from the program CS of the console application into this library. So take this out and move it into here, and we're going to clean up some of the stuff. So this thumbnailer base, I want it to be now public because I need it to be visible from outside of this assembly and abstract. The GetMetadata will be actually abstract this time. It doesn't have to be, but that's just how I want to make it. Might as well correct the spelling mistake now. And then I want okay, so the get thumbnail method, in reality, even the way you extract a thumbnail for an image, in the case of an image, you'll just create a thumbnail, but you would extract a thumbnail from a video or from an audio file. They're very different. So the get thumbnail method itself is going to be different in the different descendants. As per the .NET Framework guidelines, we don't make public methods virtual or abstract. So the idea is we have another method that has the same name with a suffix of core, and this method will be made protected abstract so that descendants can override it, while this method will remain public. Before I do that, let me also modify the signature of this get thumbnail. We'll have an image coming back from here. This image will be in system.drawing, so I'll add that reference. It should be in system.drawing. So it returns an image, and also takes in a type called media info, which is really a container class that a DTO, data transfer object, that contains a bunch of information that we might need in order to either extract the metadata from the incoming file, if you will, and or help us with creating a thumbnail from the incoming media file. So let's define this media info as well. So I'm going to create a new CS file. And let's call it media info. And this media info class is, as I said, is just a DTO it'll have to be public because the calling application, in this case our console application, will need to provide it with the information. It'll have a file name. It'll have MIME type, and it'll have a, let's see, the stream, the actual file stream. This is not for real, but I'm trying to make it as close to real as possible. And then we'll have a constructor that takes in all of these parameters. And then the file name is equal to file name, MIME type is equal to MIME type, file stream, oops, is equal to file stream. Okay, so that takes care of our media info class. I'm just going to close out this CS file. So the getThumbnail method takes in a media info. It'll most likely pass this media info to the getMetadata method as well, in case you need that over there. And also pass it into the getThumbnail core. The getThumbnail core will actually return to us the image. So this is the method that will actually get the image out from there. Maybe this metadata, in the real world, this metadata might return to you some metadata information that might be sent into the thumbnail core. We will just skip that part here. So return this, and we could probably do that. So it goes in thumbnail or base, get thumbnail, and then they'll go in here to get the metadata. This method will be protected abstract in the base class because we want the descendants to implement this method, and the reason we called it core implies, at least from a conventional point of view, that this method will be abstract in the base class and descendants will be forced to override it. So the slight change here is that the getThumbnail method is public, but it's calling now into two different virtual methods. So again, in terms of polymorphism, no matter what the instance is, what descendant instance we are dealing with, it'll certainly call this method because it's static, so non-virtual, and we're always programming in terms of the base class. And then because the instance happens to be a thumbnail or image or video or audio, it'll go into the respective base classes. So in other words, the respective descendant classes. In other words, the base class is reaching into the descendants. Okay, so now let's change the, so this is abstract here. We also need to implement in our thumbnail or image, we need to implement the GetMetadata. Something changed. Okay, we need to have a signature, so let's change that. We're missing the, why is this not showing up? Oh, abstract. Needs to be abstract. Okay, so this method we'll actually be implementing here. It won't be the real implementation, but there will be quite a bit of implementation here. What we're going to be doing for the purpose of this demo is that each of these methods for each of the descendants will, rather than extract a thumbnail somehow from an actual media file, it's going to just fake it. It's going to generate an image, a real image, and we'll have some distinguishing attributes such as the color of the image or the dimensions of the image, etc., to distinguish the image generated by this class versus this class. So we'll actually get a real image coming out, except it won't be extracting a thumbnail from some sort of a media file. But at least we'll have a get a sense of that by looking at the different images, the behavioral change. So I'll do the same for this. I'll just delete this, and so I know it's not going to work. And the get metadata, we can just copy the thumbnail or video, and we'll be actually implementing this method here. We'll also define another descendant here called thumbnail or audio. That'll have the same. What's it not? Oh, it's not returning anything. Okay. So we have the 3 classes or 4 classes. The base class that looks like this, where we have a get thumbnail that's public, calling into 2 abstract methods. Let me just move these together so you can see them properly. Okay, so there's 2 abstract methods that are then implemented by the various descendants. In this case, we've got 3 descendants, one for the image, one for videos, and another one for audio files. Okay, so now I'm just going to start implementing the one here. So in order to actually create or return an image, we'll have to create an image out of the blue. So as I said, we're not going to extract images from the actual incoming media. We're just going to create a image out of the blue. And in order to be able to distinguish one image from the image created by a thumbnail or image class versus a thumbnail or video class, we're going to change dimensions and colors and things like that, some attributes. So in this case, for images, as in for photos, if you will, they're typically 4:3 ratios. I'll have a bitmap that's 400 by 300 pixels, and then over here we'll use the graphics that comes from graphics dot from image. Now it's been a while since I wrote this sort of code, so it might take me a few tries, but in fact there's lots, I know, having done this in the past, there's lots of stuff that we need to do here, so I might just pause this video and do the code behind the scenes, because I know this gets pretty involved. Background brush 0 0 bitmap dot width bitmap dot height. Okay, I'll pause this thing and I'll be right back. I'll complete all this stuff here. Missed this one. Okay, I'm back. I decided to refactor a little bit. What I've done is I've defined a new method that's protected in the base class. So we are in here in the base class, and I call it generate image. And what it does is it parameterizes some of the attributes we would like to modify or have changed, by the descendant. So the width and the height will be changed, the color, foreground, background color will be changed, and we'll have some text in the image that we'll write out in each of the descendants. So one descendant will say I'm a video, the other one will say I'm a photo, etc. But the rest of the code is common, and so I've refactored it and put it into the base class. So now what we can do is in each of the descendants over here, so like for thumbnail or image, I can just say return get thumbnail, generate image, and I'll send it the width and height. So in this case, because it's an image or a photo, we'll have 400 by 300. Background color would be color dot I don't know, what do you want to call it? What do you want to get the background photo? Let's say it's orange. The foreground color will probably be white, so we can see the writing, and it'll return the image generated from the, did I miss a parameter here? Oh, the text, right? So the text will say I am a image, and then we'll do the same thing in the other descendants. We'll just change the attributes. So this is a video. Videos are typically HD videos are 16 by 9 ratio, so this will be 480 by 270. We'll pick a background image, background color of blue. White will be fine since we'll be able to see the white on blue. I'm a video. And then for the audio, of course this is I am a audio. Let's pick what color should we pick here? How about corn? So I have no idea what these colors are, but let's say dark gray, green. Dark green is fine. Okay, dark green and white also will work since we'll be able to read it. And thumbnail, typical MP3 files have 300 by 300 image, 300 by 300 pixel images. So we've got different behavior in each of these. We'll be able to distinguish by looking at the image and the dimensions and the colors and the text within the image that's generated. We'll be able to see for sure that these are different behavior. So at this point what we've done is we've cleaned up the hierarchy of classes. The base classes got this public method and then a protected method that all the descendants can actually use. So it's implemented here, and then it's got two abstract methods that descendants will be forced to override, because we're not really doing anything with the metadata besides writing it out to the console. Okay. Now let's get to the our console application. And this console application, we'll have to change a few things. It doesn't know thumbnail or base, but we have a thumbnail or base, except it's in the other library, so we need to add a reference to our other project, the thumbnail lib project. And then here we'll be able to reference the thumbnail lib library to add that. And now this create thumbnail is over here, but what we want to do is we want to move this over to being a factory. But let's clean this up here. So in order to get a thumbnail, we need a media info. So we'll have to create a media info. So we'll say var media info is equal to new media info, and we're able to see this media info because we already added a reference to the library. So this media info requires a file name, so we just call it some file name because we're not actually going to read into a file anywhere. The MIME type will actually come from user choice, so let's call this MIME type, and we'll add that MIME type here. And the stream, this can be null since we don't actually reference it anywhere in our code. So once we have a media info, we need to send this media info in here. What we're going to get back is an image. Images are typically disposable. We need to add a reference to the system.drawing in here as well. So let's do that from the assemblies. System.drawing. So if I look at an image, it'll be disposable. Right, it is. So we need to then wrap this in a using clause. Just in case we're not doing anything with this image, but in case we are. Nonetheless, it'll be disposable once we're done with it. So okay. So we've modified some of this, the consuming code, right? The client code in this case. In this case, it's truly a client code, as in it's another application that's using our library. Let's now work on this factory. So what is a factory? The factory is going to look very similar in terms of implementation. It's going to be looking similar to this. But it's a factory because it's a separate class that is dedicated to doing the function, in this case, of creating descendants of thumbnail or base. So it's the factory pattern. This is not the factory method pattern, which is a pattern that's in the Gang of Four book. This is another pattern. It's a very common and useful pattern, but nonetheless, it's not the factory method pattern. It's just the factory pattern. And as I said earlier, it doesn't actually use polymorphism, but it makes using polymorphism very easy, as in because it enables the idea of being able to program to a base class without concerning ourselves with how the class is actually created. And in our factory, we need to use this MIME type to determine, and here we just use letters I and V, but in reality we'd use a MIME type that will help us determine the instance to instantiate. So let's go define a factory. This factory will reside in our library project. So I'm going to go over to our library project and add a new CS file. Let's call it thumbnailer factory. And to this thumbnail factory, I'm going to make this class public. It'll also be static. The factories don't have to be static, but in this case I'm going to make it static, and it's also going to have a public static class that method that returns a thumbnailer base. And that's one of the, I guess, aspects of a factories, is that they're always returning an instance of the type base, even though under the hood they are creating the various other descendants. Create thumbnailer, in this case given a MIME type. So using the MIME type, we'll return an instance of one of the thumbnailers. So we'll do a switch case on this. MIME type, and let's say if the MIME type is audio MP3, or for now we just deal with the one type of audio file. We'll return a new thumbnailer audio. Case image is image JPEG. We'll return a new thumbnailer image, and what's the video MP4. Return a new thumbnail video. Okay, so this factory, and of course the default, we have to throw a new, normally you'd have a specialized exception in here, not the base class, but just for demo purposes I'm using the base class, and you throw proper useful exception that tells them what really went wrong. In this case, basically you got a MIME type they don't support, so not supported yet. There's always a future possibility. Okay, so here's the factory. This is as simple as it gets, and in fact this is just one implementation of how you would implement a factory. There's many variations to the theme. Typically design patterns just talk about the idea or the concept. They don't really talk to the implementation. So here's an implementation that is a factory in terms of the concept, but it's one of many implementations. In this case, what we have is the factory gets a parameter that helps us decide which instance to instantiate. That may not be the case at all times. We could have a factory that takes no parameters in, yet internally it has the information or can go get the information for which one to instantiate. For example, let's say you have something in a config file, and based on the values in the config file, you can decide whether you want to create an instance of this, that, or the other. So rather than having the caller send you the information, you could have the factory be smarter and say, okay, well, I'll make that decision. That I don't need to have you tell me which one you want. I could go figure it out myself and give you the right instance. In other words, you don't want the caller to be burdened with having to give you the information, because the caller is not necessarily aware of where the information is coming from, and the factory could be doing the job. Another variation on the theme is where you use the magic of reflection, and you essentially scan your assemblies to figure out all the descendants of thumbnailer base, and maybe these classes have some information associated to them, like an attribute that tells you that this class should be used for a MIME type of this. So the class itself is saying, I will support this MIME type, if you will. And so when using reflection, you can sort of register for the different MIME types the types that are applicable to the MIME type, and do all of this stuff kind of using reflection. So it's kind of auto magic stuff. So there's lots of variations. and they're all good variations. In this specific case, I'm just introducing to the idea, so I'm not going all the way to implementing a more complex factory. But even in real world systems, you have factories that are as simple as this. They do their job, meaning they're abstracting the creation of one or more descendants into a separate class, so that the client code is not being burdened by the need to know, if you will. The client code in this case is just saying, hey, I want something that will handle this MIME type. I don't know how you do it. I don't know what it is. I don't want to know what it is. Just give me the instance. And the other aspect is, in case it wasn't very clear, is that our thumbnailer classes here, the base class is the only one that's public. The other classes are internal. In C#, whenever you don't mark a class with an access modifier, it's assumed to be internal. In fact, I'm just going to be a little bit explicit. And yeah, I like to be more explicit, because that way, if somebody else sees this code, or if I come into this code tomorrow, I know that this was intentional, because I actually marked the class intentionally as internal. It wasn't something that happened by mistake or by fluke. So now we know that these classes were intended to be internal. And so what will happen here, and I should probably change the name of this CS file. This says class 1. Change this to thumbnailers. In the real world, of course, each of these classes will be in a different CS file, but we're not doing that here. Alright, so we have our thumbnailer factory, which is public static. In our program CS, I'm now going to use that class. So it'll be thumbnailer factory dot create thumbnailer, given the, in this case, our MIME type. So we're going to get the MIME type from our media info dot MIME type, rather than using this variable directly. That way we are ensuring that the same media info that's being sent to generate thumbnail is the value we're sending into the factory as well. Okay, the other thing just to see here, if I wanted to define a variable of type thumbnailer image, I won't see. I'm seeing thumbnailer base, I'm seeing thumbnailer factory, I'm seeing the thumbnailer lib, the actual namespace, and within that again I just see the media info, thumbnailer base, and thumbnailer factory. So these are the classes that I intended to be publicly available or visible from other assemblies, and intentionally hiding the other classes. And that's also ensuring for me that the client code is only aware of the base class, and there's no way the client code could have marked this variable to be of type image, for example, because it won't know what this image is. So that's a key aspect, as you know, of polymorphism per se. Alright, so I think we are now in a position to run this application and see what we get here. So I'm just going to run it now. This should probably be enter MIME type, so we know what we have to enter here. And okay, let's run this. Oops, there's an error here. Oh, maybe I need to clean up all these errors. Video has no constructor defined. Oh, sorry, this method needs to go, since we don't need it here. We have the factory instead. Okay, so I'm going to enter this time. I have to enter the actual MIME type, audio MP3, and what we get now is an image here that you don't see it here, but there's a height of 300 and well, you don't actually see that. Let me go into live zoom just to make sure you can see it. But for those of you who can see it, you can see that the height here is 300, and the width is 300. This is an audio file, right? So both of them are 300. Height and width are 300 here. You can't see the color or the text in here, so at least we know this part is functional. And I'm just going to run this through. So it'd be nice to be able to see this these images now, and they're in their color and their, you know, the text in there. So what I'm going to do now is I'm going to add a WinForms application, so you can see something visual here. So to the same solution, I'm going to add a new WinForms solution, WinForms project, and to this project we need to reference our thumbnail lib assembly. So let me go and do that from our solution. Okay, and let's do some design work here, UI design. So we'll have a drop down comma box, button makes the choice, and a picture box to show the image in here. Now because the dimensions of the image is going to change, I'm going to set the property here for the picture box size mode to be auto size, so it'll show us the size automatically. And what I like is for this drop down to have a list of possible options, you know, the audio, video, image, etc. So let me mark that also as a drop down style of drop down list, so we don't type in stuff, but it comes, we have to pick from a predefined list here. Alright, so in the initial, after the initialization has happened, we want to be able to fill out our comma box with a bunch of items that'll have the MIME types in there, and also the words audio, video, image, etc. So that's going to require a bunch of classes. So again, what I'm going to do is, rather than bore you with the actual typing out the classes, I'm just going to pause for a bit, do the coding, and then I'll be right back. Okay, I'm back. What I've done is I've defined a new class called MIME type display that contains the display name, which would be the audio, video, photo, image, and then the MIME type that's associated to that. So audio would be, you know, audio MP3, video would be video MP4, etc. So this is just a regular DTO or a model class. And then in the dropdown in the forms constructor, I essentially add in the different MIME types that we support here. So the display name and then the MIME type. And I tell the comma box to use as the display member the display name property of this object here. So that's that. And then when we click on this button, we should be able to extract the selected MIME type, if you will, and then call into our, so the code in the form will look similar to our this program file. So it should look very similar to this stuff. So I'm just going to copy this, or we don't need the using in this case because we'll be assigning it to our picture box. So in the click event, it'll be something like this. I don't know what exactly it's going to be, but let's define a MIME type that comes from the comma box one. Let me move this up a bit. One dot selected item. The selected item is of type this, so I'm going to cast that, and then I should be able to dot into this to get the MIME type. So that's the MIME type. Doesn't know media info, so I'll add the namespace there. Okay, so we have a MIME type extracted from the selection in the dropdown. We've constructed a media info from that. We've sent in the media info to the thumbnail factory, and so we don't want to using here. What we want to do is assign this to picture box one dot picture image, and that should take care of our. Okay, so let's see if this works. I need to set the Windows application as the startup application. So we run in here, and its audio is already selected, so I'll just hit button 1 here, and you can see it's so audio is a square image. It's a green image and a square 300 by 300, and it says I am audio. pick image, and it's an orange image that says I'm an image, and it's 400 by 300 pixels, which is also correct. And then we pick video, and we have a blue image that says I'm a video. And so basically this is working. What we have here is based upon user choice, behavior changes, but our code is not going through contortions to say, well, if the user picked this, then do this, that, and the other. It's using a factory to create an instance of a class that has that behavior encapsulated within that class. And with the help of a base class and some functionality, the descendants are purely concentrating on or concerned with the differences in their behavior. I can improve this a little bit. Maybe I should just, as you pick the different items, the change event should fire this thing. It's just a little, it's not making any difference to the actual topic in hand. But so if I were to in the events, what's it called, change event, I have no idea what the event is, but I'm guessing it's a change event of some sort. Here it is. I'm going to assign it to the button one click itself, so that way it's not rewriting any of the code. Let's see how that works. Right, so it's changed in the first go, so it's already selected the audio, and then I should be able to just scroll up and down and then drop down to see the different behaviors. So there you have it. So a little more real world. It's there's lots of things that I wouldn't do in real world application, but I guess you get the picture. We have also looked at the thumbnail or factory, in this case is the factory pattern, and we've refactored our code a little bit. So this takes care of the understanding polymorphism part 2. Of course, not a lot of polymorphism, not a lot of harping on the polymorphism part, but introducing you to the thumbnail or factory and refactoring the code in a way that would be a little more real world. And of course, these thumbnails are actually doing something. They're not actually creating thumbnails, but they're certainly creating images with different behavior. So you can see the behavioral change, in this case visually, because we were using a Windows Forms application. Before we leave, I just want to again reiterate or harp on this idea that the client code is written in terms of the base class at all times, and the object is manipulated in terms of the base class as well. In other words, the only methods you will see on this variable is methods available to the public methods available on the thumbnail or base, and that's the key, one key aspect of using polymorphism in your code. And we do this not only in the console application, but we also do this in the form application or the form class, where it's exactly the same idea. You have a variable defined as thumbnail or base, and it is being manipulated using or manipulated uniformly using, of course, all of the interface of the thumbnail or base class and not any of the descendants. And so this code, neither of these two pieces of code is aware of any of the descendants, which is the key aspect. So I hope you enjoyed this episode, and that I've done justice to giving you some indication of a more real world use case of polymorphism. Thank you.